So, welcome to this video, and in this video we're going to talk about the representation of graphics. And you've already done a poster on this, and I just wanted to talk to you just to get this into your head about how we answer some exam questions and go through some theory. So we know that like text and numbers, graphics or pictures, CPUs process those as binary. So all data must be converted into binary in order for the computer to process it. And there are two types of ways of storing pictures. There are raster images or vector images. And one type of raster image is a bitmap. Okay, and a bitmap, okay, is basically a picture made up of, in terms of size, in terms of bits and pixels as well. So if we look at this simple diagram here, we've got a picture, we've got 4 squares in there. Each one of these squares is a pixel, okay, and in this case, this pixel is black, okay, and it's got 1 bit. It's storing 1 bit of color depth, okay. So that could either be, in that case, if we think about doing 1, 2, 4, 8, 16, 32, 64, 128. If we think about 1 bit, that's either 0 or 1. And programmers over the years have allocated colors, okay, to bit depth and combinations of bits and numbers as well. So if you wanted a shade of pink, that has its own particular binary code. Okay, so that's a little bit of an introduction to that. So it may be very simplistic to say we only need black and white, but actually we need color, don't we? So let's talk a little bit about color depth. So within pictures and so on, we can actually say, well, let's have a more detailed color. So many images need colors. To add color, more bits are required for each pixel. For each one of those squares, we can actually have more bits in it. And the number of bits determines the range of colors, and this is known as the image's color depth. Okay, so let's just have a look at this particular chart here, and which got a very simple 8 bits. Okay, so this is talking about what's in one of these pixels. So if we wanted a 1 bit, remember a bit is a unit of storage, what could we have? Well, we could only have a 0 for a 1 or a 1 as a possible. Okay, so if you've got 1 bit, you can only have a 0 and a 1 because it's 1. So the colors possible are two colors. So 0 being black and 1 being white. Okay, now if we then doubled up and said, well, what about 2 bits? What if we doubled the number of bits we had? So we could actually have either 0, 0, 0, 1, 1, 0, or 1, 1. Okay, and they actually 0, 0 is black, 0, 1 is actually the color dark gray. You didn't need to know this. Okay, and 1, 0 is light gray, and then 1, 1 is white. So that gives us more of a depth of color. Okay, so what are the potential color options there? So 1, 2, there's 4, aren't there? Okay, what about if we had 3 bits? So we could actually store 3, so we have 0, 0, 0. Okay, we could have 0, 0, 1, 0, 1, 0, 0, 1, 1. Hang on, I missed a letter out there, and so on. And then you can have 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, and 1, 1, 0, 0. Okay, and those are actually colours on their own, all right? And you can actually get possible colours of 8 in there as well, okay? So this becomes a useful way of expanding the range of images. And as computers developed and so on, they got the ability to have more colors. So if we then go on to an 8-bit image, you can have 256 different colors. And remember, that's for if they're actually binary values. So each one of those bits here could have a different binary values. And the more bits, you might have 8 bits stored here, 8 bits stored there, 8 bits stored there, and 8 bits stored there. So as you can see, as the more depth of color happens, the greater the size of the image will become. So just to summarize that, so if you have an 8 bits per pixel, that allows you 256 colors for that pixel, or 1 byte, okay? Because we know that 8 bits is 1 byte, but if you've got something that's got 16 bits per pixel, or 65,536 potential colors, okay, that is 2 bytes per pixel. Okay, I hope that makes sense. So let's have a look at image size. So if sizes images are normally done by height, by width, and you probably notice this when looking at monitors or resolution of certain things. Okay, so you can say, well, an image has 350 pixels high and a width of 400 pixels, or whatever combination. Typically, some laptop monitors have a resolution of 1024 by 768. That's a very common image size. Another question you might be asked is how to calculate the file size of that image. In this case, we have an image which is 100 pixels, okay, and the width is 200 pixels, and the color depth is 2, just to keep it very simple. So what would the file size be in kilobytes? And we know that 1,000 bytes is 1 kilobyte, okay? So the sum would be 100 times 200, okay? Which is going to be what? That is going to be 2 and 4 zeros. So that's going to be 20,000 pixels, okay? What you then do is you times that by 2 to get whatever. So what's 20,000 times 2 is 40,000. Okay, you have 40,000 bits. Okay, and to get to the actual what's it called, the actual kilobytes, okay, we need to do 2 steps. We need to divide that by 8 to get the bytes, okay, and then we need to divide by 1,000, okay, to get the kilobytes. All right, I'm just going to get I'm just going to pause this and get a calculator out just to check. And in fact, I don't really need a calculator because 40,000, so 40,000 bits, and you know that 1 byte is 8 bits. So we divide that by 8 to get 5,000 bytes. Okay, divide that by 1,000, and the picture size is 5 kilobytes. Okay, so we need to go from a total down to bytes, down to kilobytes, to often do that. All right, so that's a bit about calculating the file size. So finally, if we have a look at image resolution, and if we look at these cinema screens, okay, these are the latest. These are very rare in cinemas at the moment. You would normally get a 4K screen, say at your local Odeon or whatever it was. And it's really how many images, so how many pixels wide and high does your screen have? And it all depends on the quality, depends on the screen size, okay? So be aware of that. But fundamentally, a 4K screen that you get at the cinema would have 3,840 pixels wide and 2,160 high, okay, which is millions and 8 million odd pixels. So the more pixels you have, and obviously you've got here a very high rated color depth. If you look at it, okay, these are big file sizes, these movies, when they are actually shown. And 8K is a lot bigger. And it depends, you know, in terms of the pixels. So the more detail, the more color, the more realism, and so on that's going to have. So resolution is about how many pixels it is wide by high, and then you can do a calculation to work out how many pixels are on the screen. Okay, so thank you for watching this video, and we're now going to have a look at some questions.